Hello friends, let's look at event-driven architecture in this video. Event-driven architecture is widely used in microservices and also for passing information between heterogeneous systems that are monoliths. There are mostly three actors involved in this architecture: the producer that sends the event, the consumer or consumers who receives the event, and performs some processing after the reception of the event. The third component is an event broker. In most cases, this is a separate system that provides APIs or interfaces for the producer to send events and a set of APIs for the consumers to register for an event. The communication, storage, and propagation of the event is taken care by the event broker. Few examples of event brokers are, say, RabbitMQ, NATS, Kafka. Typically, event brokers provide pub/sub capabilities. The service that emits the event is unaware or doesn't care when or what the consumer does with the event. The sender is totally decoupled from the receivers. Let us look at an example. There are three participants in this example: the checkout service, email service, and audit service. When checkout happens, the checkout service emits an event, and this event propagates through the event broker. The broker provides this event to the email and audit services as they have registered with the broker for this event. The checkout service is unaware of what happens to the event once it emits the event. The sender and the consumer is totally decoupled. So this is one of the big advantage with this event-driven architecture. This is a sample pseudocode that shows the interactions of the services with the event broker. Advantages of this architecture: the sender and the consumers are not directly connected. The communication between them is asynchronous, and the consumers and the sender can scale themselves independent of each other. This means you can allocate more resources to the consumer if the consumer is doing some heavy processing. In case the consumer goes down, the broker will ensure that the message is delivered to the consumer when it is up and running again. So this is a great for failover. Thus the system is able to handle failures very well. This architecture is well suited to integrate systems. Those are very different. For instance, a Java application can talk to a .NET application or vice versa. So let's look at some of the disadvantages of this architecture. There's a possibility of receiving the same event more than once. Hence, the consumer should take care of this scenario. Brokers supports various kinds of consistency settings for message delivery. Choose the one that is more suited for your application. And the system is more complex, as the receiver should handle retries, delayed messages, duplicate messages, and exceptions. Monitoring and tracing is also complex and typically needs a common trace ID to correlate the logs of the sender and the consumers.